Hello and welcome to part two of week four, which is going from July 28th to August the 3rd, differentiation in math, elementary and secondary settings. And we have part three, which are the videos. Sorry about sometimes fumbling over my words. By the end of the night, I'm typically extremely exhausted because I've done about 60 jobs in one. I do not advertise PhD programs to people because they literally exhaust you. And sometimes I think, am I getting dumber or am I getting smarter? Anywho, and also as I prepare for the school year, it seems like I'm exerting a little bit more energy. So leaving me with little to nothing. So sorry about that. I know that can be kind of a nuisance if you're like, come on, lady, get that, whatever you're trying to say out. Anywho, so excuse me. But this week should be another edition of something that helps you figure out how to differentiate a little bit better. And just, I want to say the reason why the course is set up this way is so that you have very sound examples that you can apply within your midterm. So you are not being required to teach the instructional approaches because you're not in school yet, or not back to school. But it should be very clear that you've viewed and also read about applying these instructional approaches in a very in-depth manner to where they are effective. So I shouldn't have to guess to know if you know how to use these. For this week, we'll be focusing on exploring methods of differentiating within everyday mathematics, and then reviewing zone of proximal development, and then also examining some essential lesson components to add to a math differentiated class. But these things can be added to any class, as I've stated before. The third part of this week's lectures will provide examples of how to differentiate through instructional approaches for ESL students, and that was intentionally selected within a secondary setting just so that you can see how she approaches it. And then the other one was station rotations, which was really hard to find. That one is really long. I'm just going to give you a warning. And also the teacher is very quirky. You probably kind of like myself. So I enjoyed it. However, just brace yourself because she is long-winded like I can be sometime, and she also is quirky. But if you can get past the quirkiness, it is really a useful video. I was like, wow, I like her cart that she has going on. She teaches second grade, and then her ideas were just awesome. So just hang in there and try to see the examples that she has. So they start off with this quote that I thought was really important, and this whole entire thing came from a chapter in McGraw, so I'll bring over the text really quickly. Here, so as you can see, it's a part of a larger book, and the title of the book is on the side if you wanted to actually purchase the book, Differentiating Instruction with Everyday Mathematics, and then the copyright is on the side. I always find free resources for us so that you don't have to purchase the things that someone else probably copied and put out there. But just in case, if you want the actual original thing, feel free to go to that source. But this is really awesome because it breaks down the components of an actual, a really great lesson for showing how to differentiate. So they break apart each of the aspects of this particular lesson, which is in some type of textbook for teachers. But what you want to focus on are the things that they have in it, not necessarily the fact that you don't have that resource, but the things that they have in it, and then the breakdown. And then the other thing that I've provided for you is the why and how to differentiate math instruction, because there's two components to differentiating. So as we go through it, the first one we start with was the McGraw chapter, which was an addition. But they start off with this quote: "Good teaching requires some degree of differentiation for every student every day. However, most discussions about differentiation focus on groups of students who typically require more differentiation than normally expected." So I think sometimes this is an excellent point to make. We go into a lesson thinking that we're doing all that we can for the students, but really a lot of them need a lot more. And this becomes very important in math when students have severe gaps in their skill ability, and you're not able to answer that within just a quick fix of a rotation of stations, or just a simple example or visual aid. They may need a lot more. So there are 4 groups of learners that this chapter focuses on, and it's students who need more scaffolding, advanced learners, beginning English language learners, and then intermediate and advanced English language learners. Differentiating through scaffolding was discussed within this text, and I thought it was really critical to remember that scaffolding, it refers to supporting students' needs to assist them in developing their understanding of particular concepts and skills. But there's different ways of scaffolding that they address, which I thought was really useful. Scaffolding can sometimes be used to target the mathematical content, address habits of the mind, which I thought was pretty interesting, but it makes a lot of sense because if a student has gaps in their development of learning mathematical basics, and then they get into a higher setting, their mind habits about how to solve equations and how to adapt and adjust to word problems is going to be different, and they may need some assistance. So scaffolding and to address this possible challenge could be really useful. Next, different scaffolding can also be used to address different cognitive competencies that are required for acquiring skills such as counting, recalling basic facts quickly, or developing effective arithmetic procedures with whole numbers, fractions, and decimals for learning mathematics that requires visual or spatial understanding, such as geometry or data representation, making connections among concepts, or solving complex problems. So I think that's one of the key things here, is that you remember scaffolding to a certain degree will have to be leveled because of the fact that you don't know where the students' gaps are, and then how those gaps will appear in their ability to move on to the next skill from that basic skill. Could be impacted. So it is a matter of you kind of diagnosing, well, how would I scaffold, and looking beyond the idea of providing just one thing. So for example, my best example would be, sorry for not having the math example, but for English, when you have students who have a deficit with words, meaning that they either have a pronunciation issue or a word recognition or word comprehension issue, sometimes it starts with their ability to understand the root of the word or the suffix of the word. So one of the things I often do is I look at a student if they could spell it, if they can read it, and if they can write it. Those kind of reveal the 3 levels of the gaps that they may have, and then I work with one of the levels each way to kind of build where they have those gaps. To strengthen their skills with whatever unit that we're in where they have some word deficits. So the scaffolding happens at multiple layers. And similar to math, the scaffolding may have to happen at multiple layers, and you'll have to identify that. Next, differentiation features in lessons. I'm going through this as fast as I can. Lessons should include embedded differentiation strategies, which I thought was super awesome to point out. And these are strategies and tools woven into the core teacher and student materials and may not be immediately apparent as a differentiation strategy, versus explicitly called out differentiation strategies, which are communicated to students and highlighted to them as potential for supporting students who need additional scaffolding. So this might be differentiation options through choice boards and maybe menus that you create, versus differentiation support activities will bring the student to the level that they need to be in to participate in the lesson at the level that is required. So these can include assessment check-ins, progress check lessons, open response and re-engagement lesson components, visual aids supporting math talk in class, which I think is a vital thing that a lot of educators do not put into practice. Giving students the ability to actually speak academically. They don't have an academic voice, so you have to kind of build it in. One of my rules is that they're reading, speaking, hearing it, and then writing it. Those 4 elements are typically in each of my lessons each day. And then it says here lesson summary. So a way to connect things from the beginning to the end of the course is something that's very important when you're talking about differentiating within a math setting. Next, why and how to differentiate math instruction. So this is the second article. It says here that excellence in mathematics education requires equity, high expectations, and strong support for all students. That's a part of the equity, meaning that every single student that walks in a room will have the ability to access the things that are required in order for them to develop the necessary skills or learn the new skills that you are discussing within that lesson. So some of the challenges they highlighted in grades 6 through 12 included that students come in with these ranges of skills, and once they get to you, you don't know sometimes where things have fallen apart. So it's your job to diagnose, challenges, and also begin the process of finding instructional approaches that will equip the student with what they need to bridge the gap between what they need to know and what they know now, which is a challenge. And I'm glad that they spoke about that and recognized it. But one of the things that you can do is focus on the zone of proximal development. I know we've all heard of it, but remember, zone of proximal development is used to describe the distance between the actual development level as determined by independent problem solving and the level of potential development as determined through problem solving under adult guidance or in collaboration with more capable peers. So this is important because you want the student to get to the can, but you want to be able to usher them into the can with support, a lot of support, meaning that they should feel confident and comfortable in failing with the fact that they have guidance in that failure, if failure arises, until they get to a point where they can be successful at this skill. The red zone is can't, and then their zone of proximal development is in between the can and the can't. So it's your job to build between these two areas and ensure that students can bridge into the can and don't decline or go back to what they can't do because they may not feel comfortable in the environment or confident in the environment. So when you are differentiating within content areas that have a lot of rigorous skill demand, it's important that you consider their zone of proximal development and build your differentiation around that range to ensure that they're moving towards a healthy disposition in regards to your content area. Finally, we end with the principles and approaches to differentiate instruction. The article stated, or this chapter stated, there is general agreement that to effectively differentiate instruction, the following elements should be added to differentiation teaching approaches: big ideas, prior assessment, and then choice. I think we all kind of add some of those elements within it. Please take a look at those so that you can explore further. At this point, you should have already done the reading. This is a recap of all the reading, so it should be helpful. But these models I thought were the best ones I've seen thus far. So the first one is the 8th grade classroom, the 8th grade math ESO class, where the teacher is differentiating with a lot of the skills that were mentioned in this reading. And then the other one is our quirky 2nd grade teacher who does math rotations. And I thought this one was pretty useful because you can see how she sets it up so that the students can rotate successfully within the elementary setting. So with that kind of wraps everything up. I hope that you enjoy these 2 examples. I loved her rotation sheet that she has for students to complete the activities. I think I'm going to apply some of that. But yeah, it was super awesome. It is long. It's about 30 minutes. Hopefully you can get through it and kind of pick up some important skills or resources for you. She also has a link to some of the things that she uses. So if you wanted to buy some of her things, that you could, but it's up to you. Teachers pay teachers. Anywho, I hope you enjoy this version of differentiation by looking at the math content area. And I hope that it provides you with something else that you can use that you hadn't previously used before. And this wraps up this lesson. 4 minutes over. Sorry about that. I hope you enjoy your weekends and have a fantastic day.